Hi friends, welcome to this channel. In this video, we are going to look at problem 1590, make sum divisible by p. This problem actually is a typical problem, so we can solve it using dictionary and check method or strategy. But here, we need to use prefix sum modulo p, right? So first, let's quickly look at the problem statement, then we look at the basic main idea, and then we look at the coding. So here we are given an array of positive integers called nums. So we want to remove the smallest subarray. Smallest is in the sense of the length, right? So we want the sum of the remaining elements is divisible by p. We are not allowed to remove the whole array, right? So we want to find the length of the smallest subarray that we can remove to achieve the above goal. Otherwise, we return -1. So if you look at the three examples, the last one, so the sum is 6 and the p is 3. So 6 is a multiple of 3. Therefore, we can remove an empty list. Therefore, the output is 0. For example 2, so the total is 9 plus 7, that's 16, right? So we need to have a 9 left. So we can remove, for example, 5 and 2, right? So for the first example, so the sum is 10, right? So we need to remove a 4, right? So here there are two possibilities, at least. So you can remove 3, 1, you have a 6 left. Then you remove this 4, you also have a 6 sum left. But in the sense of smallest in this problem, so we need to remove this one. Therefore, the length is 1, which is also the return. So if you look at the constraint, so here, this is the length which determines the problem size. And all the elements are positive. And another important one is that p is strictly positive. It's greater than or equal to 1, right? With that said, actually, we are ready to look at the main idea. So if you have practiced quite a lot, you should be able to recognize the pattern. So here, if we call s, the lowercase s, the sum of the array, then we can compute this target, which is s, the remainder of s divided by p, right? In other words, s modulo p. So the question actually is reduced to the following. So we want to find the shortest subarray. So let's call it sub, such that this subarray has a sum which modulo p is also target, right? So then if you consider the remainder will be a multiple of sum. The sum of the remainder element will be a multiple of p. So then in order to find this one, so the smallest subarray such that the sum modulo p equals the target above. So this can be easily solved using prefix sum, right? So this problem, the important case is to deal with edge case. In other words, when the target is 0, right? So here we are going to use dictionary. So the dictionary will be store, so the key, a value of pair, right? So the key will be the prefix sum modulo the p, and the value will be the last thin index for this key, right? So we will initialize that using dict. Let's say d is 0 or -1. So this is counting the empty ones or the one starting from the beginning, right? So with that said, let's look at the coding. So first, we can get the target. So the target will be the sum of these nums modulo this p, right? So here we can initialize a result variable. Let's call it float infinity. The reason we use this float infinity is due to the fact that we want to find the minimal one. But also, it's not allowed to remove the whole array. Then a better way here, it might be just use this length of this nums, right? In other words, we want to find a larger number because we are going to take minimum. So first, the edge case to be treated is if target equals 0. This means the sum of the list is already a multiple of p, right? So we don't need to remove anything. Therefore, we return 0 in this case. So next, basically, we are going to run the dict and check strategy. So here, what we can do is first, we can initialize a dictionary, right? So we pretend that a key, right, with 0 means it's starting from index -1, right? So this way, when we have another index has a certain sum, then we can just use the index minus this previous last seen index for a certain value. The reason we are using -1 is due to this fact. For example, if you have an count index, the array starting from L and ending at R, the length will be R minus L plus 1. But here I'm using not 0, but -1. So this way I don't need to consider the plus 1. But this is at our disposal. Once you have a fixed convention, you can make it right. So now we have a current. This is a running sum in the sense of modulo P, right? Now that's a basic for loop. So for I, Y in enumerate nums. So here we track the index is for computing the length. First, we get the current. The current will be current plus the current value. Then modulo this P, right? Then we want to check. So we want to check this one, the current minus the target. If this guy appears before, right? So we can find this index, and then using the current index minus that index, it will be giving the piece of subarray length deleted. But this current might be less than target. Therefore, what we want to check, let's see. Let me first write in a more lengthy way, and then we are going to shorten it. First, if the current minus target is greater than or equal to 0, then what we want to check actually is current minus target. Otherwise, we need to borrow a p, right? Check equals current minus target plus p. So then what we want to do is that if check in this d, so we can find the last time, the latest time we see this sum modulo in the sense of modulo p. So this will be this one, right? This is be d check, right? So then from the current index minus this index, let's call it I0, then from I0 plus 1 up to this I. So this is what we want to delete, right? So this is the ending at this I, and so the subarray we are considering is starting from this index d check plus 1, then ending at I, right? So the length is this one. So what we want to find is actually this minimum of this one, the previous state and the current one, right? So then no matter what, we are going to update the current to be I. The reason is that our dictionary will store for each current the largest index. In other words, the most recent thing. This is going to make the removed subarray shortest, right? So then afterwards, so we can do the return. So we want to so first, if a result is less than the length sum nums, so we are going to return result. Otherwise, so we are going to return -1. Let me first run it to test if it passes all the cases. Yeah, it passes all the cases. So now I want to make some simplification. So especially this several lines. So this several lines actually can be shortened into one line. So we are going to use this. Check equals current minus target. Because we are doing modulo p, so this one might be negative, but if I add p, it will be always positive. Then I do again a modulo operation. So this is for sure in between 0 and p, and also especially non-negative. So we can delete this part or comment out this part, right? So this 5 lines is for details. So if you realize the algebra, so you can directly have this one. Then you do check, right? And now let me submit. Still positive. And here we can also simplify a little bit. So we can return result if result is less than this one. Otherwise, so -1. Let's submit that. Yeah. So I would say this problem is a very good problem. Actually, it's a typical problem for using dictionary and check strategy. So here it incorporates prefix sum modulo p. So with that said, that's it for the current analysis of this leetcode problem. Thank you for watching.